Hello everyone, we're going to do a quick example problem on how to construct a one sample t interval for means. So here we go. Here's the scenario. The usual chirp rate for male field crickets varies around a mean of 60 chirps per second. To investigate whether chirp rate was related to nutritional status, investigators fed 32 male crickets a high protein diet for 8 days, after which the chirp rate was measured. The mean rate for crickets on the diet was 109 chirps per second with a standard deviation of 40. What we're supposed to do is construct and interpret a 99% confidence interval for the true chirp rate for crickets on a high protein diet. So since we're being asked to construct an interval, we're going to follow our panic rules. So first let's figure out what we know. We know x bar was 109. We know that the standard deviation of the sample was 40. We know that the sample size was 32. Everything else is extraneous. We don't need to know about the 8 days, and we don't need to know about the usual chirp rate is 60 chirps per second. We just need to know what the sample's chirp rate was, which was 109. We need to test our assumptions. Now, this is not a simple random sample. Instead, this is an experiment. So we can say that the data was obtained via a controlled experiment. We also need to establish whether the data is normal or approximately normally distributed. It doesn't say that up there, but we do have a large sample size. So due to large sample size, greater than 32, n is greater than 30, we may assume the data, the distribution, is approximately normally distributed. And the third assumption is sigma is unknown. Okay, we need to name what we're doing. We are going to construct a one sample t interval for the mean. Okay, now we need to come up with our intervals. We're going to use our formula. Remember, the formula is x bar, so 109, plus or minus. Now we need a t statistic, and here we're going to have to do a little bit of investigating. So I'm going to show you a couple of different ways to come up with the t statistic. The first and easiest way will be to go into your textbook and look at table B, which you can see here. So we want a 99% confidence level. So we would go down here to 99%, and then we have to remember what our degree of freedom is. So our degree of freedom in this case, we had a sample size of 32, so degrees of freedom would be 31. So we would start at our 99% and we would go up until we get to, well, 31 is not listed, so we can't pick 31, but 30 is the next number smaller, so we can use 30. So we could use a t-statistic value of 2.75. That would be approximately, the closest degree of freedom that we could find using the table. So that would be one option that we could do. Alright, so we can go back over here and we could use that number and stick that number in there for our t-statistic. Another option would be, if we wanted a more precise one, we can go into our calculator and do second distribution, and we're going to do an inverse t. So that's number 4, an inverse t. We want a 99% confidence interval. So if you picture this on the graph, that means the area underneath the curve is going to be 0.995. Because remember that we have 0.5% on the left and 0.5% on the right. So that 0.5% is why the area is 0.995. With a degree of freedom of 31, and then if we look that up, it will give us something a little bit more precise than what the chart gave us. The chart gave us 2.75. We have an interval of 2.74. So 744 times, now we can use our sample standard deviation divided by the square root of 32. Now once again, you have the opportunity that you could just plug all this into your calculator and calculate it by hand, or you can do what I'm going to do, which is go back to my calculator one more time, go over to tests, go down to t interval, it's number 8. We have the stats this time, so we put in the stats. X bar is 109, standard deviation of 40, n of 32. We want a confidence level of 0.99, and then we go down and we hit calculate. It thinks for a minute, and there it is. It gives us our interval. So we have an interval of 89.6 to 128.4. And then that's going to be our interval. So finally, our concluding statement. Our concluding statement would be that we are 99% confident that the true mean rate for we're going to go back a minute. We are 99% confident that the true mean rate of chirps for crickets on a high protein diet, notice how specific I'm being when I'm writing all this out, on a high protein diet is between 89.6 and 128.4. And then that's your answer. Now don't forget, somewhere in here also you should state your degree of freedom. So even off to the side here, one sample t interval for the mean. You can calculate your t-statistics, so I'm just going to off to the side write degree of freedom df equals 31. Anytime you're doing a t-test or a t-interval, and I just realized that I forgot to do this on the previous test, you should always somewhere in your write-up indicate what your degree of freedom is, just to kind of cover all your bases. So hopefully that clears some things up for you, and I will once again see you tomorrow.